Welcome to Advanced Fluid Mechanics. My name is Brendan McDonald, and I'm a professor of mechanical engineering at Ontario Tech University, which is located in Oshawa, Canada. So this is the first video in Advanced Fluid Mechanics, and what I'm going to be doing in this video is a brief introduction to the course. So this Advanced Fluid Mechanics course is typically taught in graduate school. So at Ontario Tech, I teach this course as a grad course, which means it's taught to master's and PhD students, usually in mechanical engineering or related fields. So I teach another fluid mechanics course to undergraduate students, and I have all the videos for that on my YouTube channel as well. So we would know from that course that fluid mechanics is really important because it tells us about mechanics, which is the forces of fluids. And this is relevant to so many different interesting things. So the lift of aircraft is generated by a fluid, which is the air around the aircraft, and the forces that lift it up. So that's classic fluid mechanics problem. Also things like air pollution and where it flows, design of things like turbines, heat exchangers is a fluid mechanics problem. Also things like rockets or drones or racing cars. All of these are things where the fluid forces are critical. So the question then is, how is this advanced fluid mechanics course going to be different from that undergraduate level fluid mechanics course? And the answer is that we're actually going to look more closely at the mathematics involved. And so we're going to aim to understand these fluid mechanics problems more deeply. So an undergraduate level fluid mechanics course will teach you all about fluid mechanics principles and apply them to design lots of different things. But where we go at the advanced level is we're looking at designs that might be a little more challenging or a little more complex, right? And so we need to use the mathematics to tackle these more challenging types of problems. And this is why advanced fluid mechanics is typically taught in grad school, because the focus there is a little bit more on innovation and research-based projects. So what we're going to be learning in this course, where we look at the mathematics, is scenarios where we might be pushing the envelope a little bit, designing things that had never been seen before or are a little more innovative, right? So we're pushing the boundaries a little more. And that's where the advanced fluid mechanics is going to differ from an undergraduate level fluid mechanics course. Now, ultimately, the math does have its limitations. So at some point, you may have to rely on experiments or models, and we'll talk about when we would need to do that throughout this course as well. But ultimately, the math is going to be really powerful, and it's going to help us in coming up with cutting-edge designs and predictions or optimizations of different things. So the emphasis, like I said, is going to be on the math, and we'll look at really understanding the underlying concepts, which will help us be better designers for fluid mechanics problems. And ultimately, because we want to be using fluid mechanics to solve actual problems, we'll be referencing applications along the way in this course too. So there's a few different goals I have when I teach this course. Number one is always to show you how interesting and exciting fluid mechanics can be. So hopefully I can increase your curiosity and interest in fluid mechanics. Also, fluid mechanics is a fairly broad field, so there's a lot of different disciplines that will study fluid mechanics, including mathematicians and physicists and different types of engineers. So another goal I have in this course is for you to be able to read and to appreciate any type of fluid mechanics problems you come across, say in the literature or in textbooks. So I'm going to make sure you have an understanding of all the different symbols and mathematics used. So no matter what field you're reading a paper from, you can appreciate it and analyze it and potentially use it, right, to help you solve your fluid mechanics related problems. And ultimately, I'm an engineer. So I'm going to always want to relate my course material back to solving of actual problems. So making sure you can apply this mathematics to tackle actual problems. So throughout the course, we'll be using examples for that as well, making sure we're tying in the mathematics to the actual applications that you'll see as well. Okay, so that's a relatively short introduction. Hopefully it helps you understand what this course is and what's different about an advanced fluid mechanics course. And then in video 2, I'll start getting actually into the material so we can start looking specifically at the fluid mechanics in more detail. Okay, thanks for watching.